So welcome back, everybody, for this second session on software. The next presentation is about simulation using the Tango framework. The presenter is Rubio-Manrique. He has been doing a lot of very interesting things: artificial intelligence, domotics, Internet of Things, and then at a certain point, 10 years ago, decided to join ALBA. And he is coordinating now the Machine and Protection Software Group.
Thanks. Well, hello to everyone. Let's start with the topic of my talk. It's the simulation or approach to simulation, and it's reproduce anything, anywhere, as basically we are running facility. So I will introduce a bit. We are, since 4 years ago, applying some agile development principles, continuous delivery and integration. So as most of you already know, the goal, in case of continuous delivery integration, is to deliver frequent, well-tested, small upgrades to the control system in order to continuously improve the system while building confidence on operators. Well, well-tested is one thing, small upgrades is another one. Actually, we are a team of 4 people, upgrading more than 100 control room applications, from SUSE 11, that it's quite old, to Debian 9. We are moving from RPM to Debian packaging, from Tango 7 to Tango 9, from Taurus 3 to Taurus 4, from a polling-based control system to events. This is because we are changing archiving from HDB, TDB, from Solid to HDB++. Fortunately, we are not changing anything on the hardware. And we are just migrating the tools from one framework to another one. We are trying to not modify the application so much because it would be a hell if we have to change so many things. And this without shutdown time. I mean, we are doing that while the machine is operating, and we have to keep the application running for users. Well, typical testing techniques: unit testing, functional testing, integration testing, regression testing. We could say that, well, this joke about unit testing is the new compiling. I mean, now we have moved all to dynamic languages, but now there is a newer step that everyone is incorporating on the development, that is unit testing. But all these kind of testings have a bit of a drawback in the sense that, for example, unit testing, it's very important to do it on an API or on a big new project. But for old projects that were developed time ago, that has very old codes, not maintained but working, I mean, which profit we have on modifying the code to introduce unit testing for that? Functional testing without hardware, it's always a problem. We require simulation. For integration testing, sometimes we do it on a mock-up, but the difference in infrastructure makes the integration testing not so profitable. And finally, regression testing. For many of our technologies, it's not a matter of regression. It's simply that the old technology is not available anymore. It's obsolete. It's not possible to update or to test or compare with the new one because are different paradigms. So, well, my question is, does it really pay off? We think that yes, but it pays off when you really are taking some profit of introducing all this testing in the development process. So we are now taking an approach for testing use cases. So while developing, we are running real application and test environments, doing regression tests, measuring memory usage and CPU usage with the new versions. We are doing continuous integration using Jenkins and Travis for some big projects. So, well, verify code correctness, unit testing, for some libraries, functional testing, integration, regression. And then there are other kind of tests that we do that are tests in production. We implement something that we recently know that has a name, but probably all of us is doing at some point, that it's canary testing. So not upgrading the whole system at once, yes, upgrading on a small part, and waiting a week to see what happens. Then, another application for testing use cases is whenever we found a bug, we try to provide a replication environment. And later, well, now we have the idea of doing chaos engineering, running experiments on the control system is something that it's a new field that seems to be being explored. What to simulate? Typically, we have many layers in our systems. So there are many places where you can put a simulator when you are doing a functional testing for a piece of software. But from my point of view, always the best place to put the simulator is as near to the hardware as possible, because then you are just simulating a small part and running the real stuff for the rest. So we have the simulator device server. It's an evolution of an old device server that was developed at the beginning of ALBA. We store small Python formulas to generate attributes. And we have used it for validating or archiving years ago. Now we are evolving it. Well, here you can see other examples of the syntax we're using to generate Tango attributes for simulation. There is the documentation of the project. Now we have evolved it to have to exploit some of the features we did for simulations. Now we are using it also on production devices. We allow the user to load custom libraries for complex behaviors. We allow templating. So let's say we want to simulate 100 ion pumps. So we have a template for the ion pump, and all the simulators load the template. And also included in a scripting layer. This is the typical declaration of a simulator. We can load some files, some libraries, and then declare some more attributes. Here we can also use data-driven simulations. We can load data from archiving to run our simulation. We can also, in some cases, mix, well, as I have shown here, well, I will let, in the cases we can mix also real data with archived data and simulated data. So in case we want to run a simulation alongside the real data to check some differences. Well, this is a typical file that is used by a scientist to declare some constants for the simulation. And then the gen simulation script, that is the new thing. This is a script that gets the list of attributes being used by a Tango client. We can export the whole configuration of these devices and attributes to a CSV or JSON files that we can move around, then generate simulations from it on a new Tango host, and apply all the configuration to these devices. Basically, the idea is we can copy and paste a real system. This is our actual use case for test environments when we want to test the new version of a GUI with a new framework on the real system without the real system. It's copy, paste, and then the simulation can reproduce archived data for these devices or just run pure simulation. CSVs. We use CSVs mostly because we have a format that is quite compact and human readable. We can specify several devices in a single file, and it's hard to extend. A format that is hard to extend, it will be kept always simple. This is, let's say, it's a paradigm that sometimes has some profit. Well, simple. This is a simulation. Here we have read and write simulation values. Of course, we can program some noises. So we can use the store values and then put noise around. We can also have some state machines. Changing the states depend on the result of formulas. We can also have some commands. Okay. And now the current use of simulator IDEs. We are using it for the testing suites of our applications. We have BACA, that is a Taurus application that integrates many Tango systems. We have Panic, or the alarm system. We have done scale tests previously on CELLS archiving database. We plan to do the same for the new archiving from the SRF and Electra. We are comparing Tango 7 to Tango 9 on Taurus 4. We simulate many subsystems that we are currently upgrading. And one point that I want to match is bug reproducibility and the chaos engineering test done on cloud. Well, this is an example of the CSV for the panic test. So we have different alarms, we have different configurations of the alarm, and then we can check a high-level alarm server against the previous condition, and later see if the results of the formulas are evaluated against the expected results. Chaos engineering, experiments in production. I talk a bit about that, but if you want to hear about more of that, it's Principle of Chaos, the web page. But basically, the idea is running experiments on your current control systems, small experiments in accommodated areas, being sure that you are not causing harm to the operation, but it may help you to have more confidence on how the parameters of configuration affect your control system. Sometimes we have systems that have been running for a long time, and we need to recharacterize its behavior in some way to know which are the limits of what we can do with this control system. So this is what chaos engineering is all about. There is a platform that is being uploaded to Amazon Web Services. We extended the scripts for the simulation to, well, as I said, export the control system to CSV file. Using the Amazon Web Services command line client, we can create new hosts. We can access to them. We can create and configure the devices from the CSV files. We can put an architecture like that with the Tango database, the archiving, then some node for alarms, another one for event subscribers, as much simulators as we want. The idea is, like I said, we take a control system, we copy it, and we reproduce it somewhere else, just for doing simulation on an environment that is as similar as possible to the real system. This approach is valid as well for model-driven simulations in which you are simulating a new system that you are developing, or for data-driven. You have a system that is already running. You have to solve a bug, but you cannot stop the system. So we try to reproduce it somewhere else. Then, my last point, bug reproducibility. Well, we always have, it's a problem to reproduce a bug in-house. You have your machine, you have a bug, and it's hard to reproduce it in the lab. But it's even worse when you are collaborating with many institutes, and the person who has to reproduce and solve the bug is 1,000 kilometers away and doesn't know anything about your system. So our approach to that is that when finding a bug in a project that is community supported on GitHub or somewhere else, we can use these scripts to create a reproduction framework for this bug, in a way that we can attach the configuration of the simulators to the issue that we're creating on GitHub and providing a tool to the developer to reproduce the bug that we had in our local system so they can solve it somewhere else. Yeah. Also, well, in these files, we can, as we have seen with the scripts used on Amazon Web Services, we can reproduce even the network infrastructure, how the different hosts and databases are distributed across the system. Well, this is a typical test case that appeared on the Tango workshop this weekend. So we wanted to check what happens if we write two attributes and one of them is out of range. So here we can copy in a CSV file the configuration of an attribute. So we can say that this is the max value. We don't allow values like 20. So we can upload this test case, create the devices, Tango to CSV, CSV to Tango, start the devices, and then cross-check that the behavior is the expected one. The first one is written, the second is not. So it's a simple test case that can be just generated with this framework. And that's all. So I finished the presentation.
Are there questions for our speaker?
No? Here?
Yeah, there.
Hi, this is really interesting. What I think it's not clear, at least not from the presentation, is you talk about a simulation device server.
Yes.
Do you use it, is the same device server that you instantiate and the only difference is how you populate the attributes? Or is this a framework that you clone and you have to do the device servers from that master device server class?
No, the device server we have our Tango device servers. What we are doing is capturing let's say the interface of the existing device servers, its attributes, commands, and states. We are reading the current values and configuration and also the buffers for all the existing attributes, and we create a new device server, so a different class, which is the simulator, but exports the same device name. So let's say it's copying the interface of the existing device, but with everything created dynamically. I don't know if I'm answering correctly the question, but it's something like not a clone, but an imitator of the original device. Okay.
But the model that you put behind this imitator is a record replay of the data, or I'm here? Is the record replay of the data on your back? Is a record replay of the data, or you put a model that executes things?
It's both things. I mean, originally we built that using models. So we have mathematical formulas that we just reproduce. Then later we'll introduce the feature of first recording the current value of the attributes and putting some noise around it that we can increase or decrease. But now what it's possible is to give access to the archiving to the simulator. So now we can set up a window of, let's say, 5 minutes and just reproduce it. And above these windows, we still can change the behavior. In the formulas, we can change, let's say, changing the state of the device, break down this connection to archiving and set it to 0, things like that.
Any other questions?
Yes.
Can you give a bit more of ideas where you use it? Do you use it also for nightly build runs, that you set up the whole environment and then do the tests, or where do you use it?
Where we use it, for example, actually the test we have done on Amazon Web Services has been just a proof of concept that it can be done. But then, for example, one thing that we did is for the project, the Tango Box project. It's a project in which we, for all people that is interested on Tango, they receive a virtual machine that currently has a simulator of the LINAC of the ESRF. But also we wanted to demonstrate our own tools without using the LINAC of the ESRF. So what we did is we created our own ESRF LINAC simulation to package with our own demo tools. So when you are using the back application, that is the demo of Taurus, it is running a simulation of the ESRF LINAC created this way. For example.
Let's thank again the speaker.